Good morning, everyone. I'm Dr. Anand Gunawardhan. I'm so happy to be part of this Open Arc C forum named Bitcoins. And thank you for the invitation to speak to you today. My job here is not to pretend like I'm a banker. I'm an academic, I'm a computer scientist. So I'm going to give you the technology perspective of sort of the computer science perspective of banking, how the things that we do in computer science actually apply to the future of banking. My background, a bit of I'm an academic. I have degrees in computer science and computational mathematics, and I've been a faculty at Carnegie Mellon and as well as Princeton. And I am no stranger to banking. In fact, when I was young, just after my bachelor's degree, I was hired by State Bank of India to be one of the management trainees. And my job, I knew nothing about banking. My job was to computerize banking in the 80s. And as you know, there were no computers in the banks those days. And they hired me simply because I knew how to program and I knew a little bit of math. And it was quite challenging, and I thought it was really fun. But I did not last there because I went for higher studies after 3 months, after spending 3 months there. Now, one of the reasons I did not last in the bank, despite the large salary I received compared to an academic career, is that when people came to bank, they deposited checks and we would enter them into ledgers by hand, and there's always the possibility of errors, and we would provide the cash to the customer. And at the end of the day, we'll have to sit down, mostly the junior officers and other people will have to sit down and balance these ledgers. And because the next day we know our Indian managers would come and ask us whether we were able to balance things. And even if there's a 1 cent difference between debits and credits, we will have to find it. And this is like finding a needle in a haystack. Sometimes one would enter 12 instead of 2, and there's suddenly a 10 cents difference in the balance sheets. And this was quite difficult to find among thousands of checks that we had to process. Now, at that time, I wondered as a young person, what can computer science do here? How can computer science find these errors faster than a human can do? In fact, computer science is really computers are good at things that the humans are not good at. We're not good at looking at large collections of things, and computers are very good at doing that. So it was the perfect application for the computers to find things quickly across thousands of records and looking at various combinations of checks and to find this missing or the input error that has occurred. And today, obviously, when I go to the bank, I rarely go and see a teller in the bank. I do all my transaction through an ATM, including getting cash, checking balances, as well as depositing checks. And my bank, I can just go to the bank and put the check. And uh, the written check is going to be scanned by some image recognition software. It will convert the handwriting into text and get me to confirm this is the correct amount. And then I will be able to deposit this check, even writing a single thing or going into the bank. And this is very convenient, especially that it saves me a lot of time since I can do this from an ATM machine. And obviously, these transactions go through ATM switches and ATM backbones into the databases and stored and accumulated and verified so that bankers can be happy bankers. They can go out and drink and enjoy life, unlike we used to do those days without the computers. Now, obviously, the big buzz these days is mobile banking because most people are really using their mobile phone quite a bit. They use the mobile phone to check remote check deposits. For example, if I get a check, I can take the picture of the check and send this image directly to the bank, and the bank would make the transaction for me. And I never have to worry about sending this a paper copy of this check. I can do all the other transactions through my mobile phone. I can do check deposits and all the other things through these mobile transactions. And as you can see from the graph here, the mobile banking has gone up quite a bit. Over 50 million people now use mobile applications to do banking because our phones now come with cameras and they are smartphones now. Now, my favorite is the online banking. Obviously, I don't remember a time that I wrote a check because all my paycheck comes to the bank and I get an electronic statements from the bank. I have a bill pay application where I can schedule payments to my gas or electric or other things. And I have 24/7 access to these things online. And that's very, very convenient for me. And as well as I can keep track of, I can look at the pie chart of expenses to see where the money is going. This is very important for me to manage my banking experience without, in fact, having any access to paper. Now, obviously, this is a very convenient way of doing banking. Now, let me get to some of the really key computer science ideas behind banking. As you know, the banking is probably the most suitable application for security. And in other words, all the data has to be encrypted. So in computer science, we have this idea called public-private key encryption mechanism, which is used by many of the encryption systems. In other words, a bank as an institution has a public key and a private key. I know the bank's public key, so I can use the bank's public key to encrypt my data, which comes in text, and send it through the internet to the bank as this encrypted data set. And this means that even if someone intercepted this data in between, they will not be able to decrypt this without having the bank's private key. So this whole idea came from computer science about using this public-private key methods to encrypt the data is the most prominent data encryption methods that's available today. And this, interestingly, there is a $1 million prize behind this. Any computer scientist who can break this algorithm for encryption decryption will be given 1 million. But that's not the problem, because if someone breaks this system, many of the systems as we know today, many of the secure systems will break and we'll be in big, big trouble. So we're hoping that no one will be able to find a solution to this. The biggest problem here is that it's actually a very simple problem, because what you're trying to find is, given a very large number, you're trying to find two prime numbers who are the factors of this large number. But factorization is very, very difficult. It can take thousands and thousands of years for large numbers for a computer to do. There's no known algorithm for doing this in an efficient way. So we are counting on the fact that no one will be able to find this algorithm, or this algorithm does not exist. Someone can prove it mathematically. And if that continues, then our encryption schemes will work in banking. And obviously, all bank databases uses these encryption schemes to store data in encrypted format. You don't want to store the data in unencrypted format because anyone can steal data from a database. So typically through a web service, you will access the internet banking server, which in turn will access the databases to provide you with the transaction. Now there are firewalls in between to make sure that all transactions remain secure. So now let's talk about how people attack sites. Now obviously one of the best ways to secure access is to access the banking website through a secure connection. That's why we have the HTTPS connections that sends a secure SSL connection. And there's a certificate from the banking website that will reach your computer and the transaction is authorized. And that's the best way to do it. But oftentimes the hackers can get into your browser and pretend like real banks and try to steal your passwords or your key to log into the banking software and make transactions such as transferring funds from your bank account. So one of the best things for you to do is to keep your browser very clean and use virus software to make sure that doesn't happen. There are lots of fake sites that are set up to look like banks, and they will try to steal your identity by asking you to enter passwords and other things. Now, these sites are very easy to set up, and so the best thing to do is to make sure that when you go to a banking site, you recognize that as a legitimate site. ATM hackers also try to steal identity through various techniques. You can even lay a thin plastic layer on the top of this keypad. So when a person comes and enter the keypad code, you can steal that when the person leaves. That's a very scary, really a thought. But it does happen quite a bit in insecure locations where the ATM machines are located. So what are the key technology challenges of the future? I think banking technology will have to deal with 5 things. Mobility, very important, and encryption, it's even more important as hackers are getting more sophisticated, and distributed computing becomes quite important, and customization and personalization becomes 2 other important things in the future of banking. So we'll have to address all of these issues related to these challenges. Now, mobility, as we know, has increased quite a bit, and people like to do their transactions through their mobile phones. Most people have smart mobile applications, cameras, and other things that enable them to complete these transactions through their phones. You can even have credit card readers attached to mobile phones. So mobile phones have become quite a bit of smart computers these days to perform these transactions. And the number of mobile users in the US has gone up quite a bit, and the trend seems to be growing at an exponential phase. The encryption, as we discussed, become quite important. We discussed that the encryption is obtained by public-private key methods, and your data is always stored in the database in an encrypted format. The problem with this is as the data grows bigger and you have large databases of encrypted data, the computing on the encrypted data is not possible, or at least not possible up to now, and it makes the computing very slow. You're trying to access certain number of transactions. It's going to take time to bring those things to your mobile phone or to your web browser. So that becomes quite a problem. The more you try to encrypt your data, the slower the transactions become. So some of the latest research trends in encrypting data is that we try to find ways to compute on the encrypted data. In fact, even if you have an attacker with the root access, database is completely encrypted, and the attacker will not be able to find the useful data from this database. And the way to do that is the research, this is the latest research that came out, is to define a set of primitive operations on the encrypted data. For example, instead of adding 1 and 2, we might say we need to add AF and BB, which may be the encrypted form of 1 and 2. Now, how do we provide, so for example, addition operations on that? So some of the research challenges for the researchers, the computer science researchers, are to find out how to compute on encrypted data without decrypting it. Because as soon as you decrypt the data, you open up your system to hacker attacks. The other challenge that's going to happen is instead of having the data in one database secure inside a bank building, we're going to have distributed databases on the cloud and various places. So the banks in various countries, say India, US, and United Kingdom, will have to be connected somehow through a network to access this data, because your data can be distributed in different places and sometimes you need to have access to this database. So there's a lot of research on distributed databases that are applicable to these encryption schemas. For example, here you could have data sources in two different places, and then the backend for the data sources. And through a federated database server, you can connect to these data services, and through a catalog, you can find the data you're looking for. There's an API, or the application program interface, through which the client access the data. So distributed databases becomes quite important computer science components in the future of banking software. The next idea of banking, I think, would be in machine learning, because as we collect a lot of data from the user, we begin to know a lot of things about the user. We can detect patterns of usage and other things that can be used in business logic to sell more services to the end user. And there's data to show that the large US bank used the IBM machine learning technologies to analyze credit card transactions. It resulted in the following. Now, when the machine learning was applied, there was a 15% increase in fraud detection. So the machines or the computers can learn over a database or lots of data to find out certain fraud has occurred in this database. And there's also an increase in reductions of false alarms by 50%, an increase in total savings by 60%. That is all resulting from machine learning's algorithms or predictive analytics applied to these data systems. And I think some of the other changes that are coming are the personalization of sites, the banking sites, to the end user. End user may have very different needs and desires and requirements when they access a banking database. So based on that, you can provide a personalized form of a user interface to the end user. And that's going to be really, really important. There will be a lot of customization of banking applications. For example, you could integrate to a banking, if you're trying to get a home mortgage, you can integrate various things such as showing the map of the home or street view and details of the house and various other things that are totally integrated into the banking application, so that one has access to information from one place. So many of the platforms allow you to include these widgets into their platforms to show various services. And so your multi-service window banking application may look like this in the future, with graphs and various other components that makes the banking a lot easier through a browser. Usability is going to be a key component going forward. You will have very easy to use, draggable kind of interface where you can access your banking information and have access to multiple things. So the usability of the site banking sites will continue to improve. Now, we've all heard about Bitcoins, I hope, and there's quite a bit of buzz about this, and this is really the hacker's dream. How do we get the banks? This is probably not the message the bankers want to hear. The question is, how do you get the banks out of the whole picture? If I want to make a transaction with another person, I can do this through using Bitcoins from person to person without having to pay a commission to the bank. Now, there are lots of questions behind this. Who is going to regulate this process? And how do you make sure that you do not lose the Bitcoins due to a hacker attack? Because there's nothing physical. This is all bits and bytes that are hanging in the cloud. And so, in fact, more recently, a Japanese bank declared bankruptcy because they could not find some of the missing currencies, missing Bitcoins. These are all digital currencies, and there's no trace of any of those things. As soon as you the idea of Bitcoin is that each coin will have a unique ID so that no one can mess with that ID. And if someone finds a way to change that ID, then you can make suddenly coins disappear. And so that's quite a bit of danger there. And also the governments are worried about the underground transactions, that you won't be able to monitor these things. How do you tax people? And I think there's a role for the banks to play. I am not sure at this point what that is. Hopefully, this audience will figure that out. And I wish you good luck in figuring that out. And as a technology person, I'm quite excited about this this effort of Bitcoins. Again, I'm not so sure how this is going to work, or this will be successful, or this will be globally accepted. But if it does, then it will reduce many of the costs associated with foreign exchanges, transferring money from one currency to another, and so on, because there's only one kind of a currency called Bitcoin. So we are all waiting to see what's going to happen here, and I am quite excited about what the future holds, and I hope the banks will play a big role in this. And to summarize things, that we talked about the mobile banking, security, personalization, service integration. Of course, I didn't talk a lot about biometrics, but I think that's going to play quite a bit of a role going forward in banking. And of course, Bitcoin with a question mark. And all of these ideas, as a computer science person, I get very excited because I think technology has a very large role to play here. And there are lots of challenges as well. And if you have any questions, you can email me, guna@cs.cmu.edu, or you can tweet me using my Twitter handle, Andy Guna. And I wish you luck with the conference, and goodbye. Thank you.